Hello, everybody. Welcome to the MySpace Megasite Round 2. I'm Aber Whitcomb, CTO and co-founder of MySpace, and I'm here with our most senior guys in our technology department, Alan Herf, VP of Engineering, who is responsible for all of our developers, and Jim Benedetto, VP of Technology, who's responsible for our operations and data services department. So we actually did this presentation last year, Megasite version 1, and I'm going to pull up some of the stats that we presented a year ago. I'm not able to advance these slides. Oh, there's one. Okay. So the first Megasite we had, this was 1 year ago, we had 64 million registered users, 38 million unique users, and 260,000 registrations a day. So we'll compare that to where we are right now. Last year we talked about some scaling milestones that we had, where we started off with basically a two-tier architecture with a single database and a couple of web servers. At 1 million users, we vertically partitioned our database architecture. 6 million users, we decided we were going to horizontally partition the databases. 70 million users, we introduced a caching tier, and we're currently at 185 million users now.
This one's not working.
Yeah, this one doesn't work.
Yes.
That one works better? Okay. Okay, so where are we today? We have 185 million registered users, 90 million unique users around the world. MySpace is the #1 most trafficked site in the US right now. Yahoo's #2. MySpace is primarily made up of about 50-50 males and females, and the primary age demo, 14 to 34. So this is an interesting slide. It kind of shows us in relation to some other sites on the web. You can see we're at the top there, just over Yahoo, and then it's interesting to see MSN, Google, and eBay and Facebook down there at around 10 to 15 million, or that's billion actually, 10 to 15 billion page views. Okay, so today we're getting about 350,000 new registrations every day. We're getting an incredible amount of static content on the site at 1 billion total images. We're getting about between 3 and 6 million new images every day uploaded to the site, and also millions of MP3s and videos as well. We measure our traffic also in terms of our number of concurrent users. We're at about 4.5 million concurrent users on the site at once during peak. We also have a very aggressive international rollout. We've localized and translated 14 countries. Just recently we launched China, which was a pretty big milestone for us. Next slide. So on the technical side, where are we with data centers? We just recently opened 3 or 4 new data centers around the country to distribute our content. We have about 6,000 web servers, 250 cache servers. We make all of our money off serving ads, so we have a very large ad serving farm as well. 250 database servers that are horizontally partitioned, and a very large transcoding farm where we have an uploading farm which moves it over to a transcoding farm, converting video and MP3s constantly. A very large SAN architecture, and we currently are using about 70 gigabits per second just on MySpace infrastructure, and then another 35 gigabits on third-party CDNs. Next slide. So let's take a look at our caching architecture. In the last year, we've really focused on building out a robust, scalable caching architecture. Next slide. So in order to be able to handle the huge amount of dynamic traffic that we have with users constantly reading and writing out of our system, we have a tier above our databases. Basically what we've done is we've vertically partitioned out our caching architecture so that our developers can build specialized caching platforms for different types of content. For example, online now. For every user, we show whether or not they're online. Also, an example would be hit counters. Every time a page is hit, we increment that. So instead of having to run all that through a database, we run it through a middle-tier caching system. In the last year, we've designed our caching system so that it can automatically replicate, which is a huge advantage for things like online now and hit counters. We can basically build redundant clusters of caching verticals. So let's say for online now, we would have, it's a relatively small amount of data. You only need a user ID for every one of your users and whether or not they're online. So, but it's it requires very high performance. So probably in the neighborhood of 100,000 requests per second. So we can write to any one of the caching nodes in that tier, and it automatically will replicate. So we can read and write from every single node. Next slide. We can drill into one of our caching tiers a little bit more. We've basically designed the caching tier to be very modular so that our developers can use different features of the caching tier and specialize it. The relay client there, that's the typical ASP.NET web server, would connect to a socket DLL, which is a very high-performance communications platform using the WinSock APIs. Then it communicates over something called CCR, which is the concurrency and coordination runtime, which we actually got from the robotics SDK from Microsoft. Very high-performance, asynchronous way of communicating. Then we have various different types of storage modules we can use. We use Berkeley DB, just regular in-memory hash tables, and various other storage engines that are specialized for MySpace. Okay, so any questions? We want to make this pretty interactive, so if you guys have any questions at any time, feel free to raise your hand, or we have some microphones right here. Okay, that's it on caching. Turn it over to Jim, or Alan, are you next?
Cool, now it works. Okay. Yeah, I'm going to go over what we do for how we manage code in a source repository, and then also how we deploy code, which is obviously a large-scale problem when you're talking to 3,000 to 5,000 servers of varying size. Basically, let me start off with talking about code management. Basically, we've adopted the whole development lifecycle to use Microsoft's Team Foundation server, Team System. We also use Team Plane that used to be part of a company called DevBiz that Microsoft recently acquired in the last few weeks. We were using it when it was a beta product, and I have to say I think we might have had a little bit to do with them maybe buying it, because we really love the interface that Team Plane had, and we had a problem, which I'll go into, where our developers could use Team Foundation Server, but our product managers, quality assurance, and people outside the software development lifecycle, business people, couldn't enter bugs, couldn't enter requirements. Our president, Tom Anderson, likes to enter lots of bugs, and he's not going to go into Visual Studio to do it, so I'll talk a little bit about that as well. So basically, MySpace embraced Team Foundation Server when it was in Beta 3. We moved away from Visual Source Safe. We were one of the early TAP program members for both SQL 2005 and for Visual Studio 2005. So we went ahead and took Team Foundation Server as well and started to work on that. And that's also when we started using Team Plain, because we really didn't like the interface, the initial web interface in SharePoint. So we wanted to find something more robust, and we happened to find Team Plain. Team Foundation Server initially supported about 32 users 32 developers for us. We now have about 110 and growing. Next year, we'll have about 240 developers using it. We worked pretty heavily with a gentleman named Brian Keller at Microsoft who the next version of Visual Studio is being used in the source repository for TFS. So they're a way bigger client than we are. So I don't think we're going to tip it over, but it's helped us learn a lot about the product. MySpace is able to branch and shelve a lot more efficiently. We do a lot of work. We'll want to shelve something in a team, and we'll want to unshelve it to basically merge it back into the main code branch when we need it. We do a lot of experimentation. We also use Team Foundation Server for our C++. We wrote a MISQ provider, an MSCCI provider for Macromedia to work in it, as well as for our Cold Fusion code base. MySpace is still about 20% Cold Fusion. We're about 80% .NET now. So MySpace has been a member of the SDR, the Strategic Design Review for TFS, and that's really helped us give our feedback to Microsoft. What's also helped us is we were trying to make a decision between another product and Visual Studio Test Edition, and we didn't know if Visual Studio Test Edition would be robust enough. Now, we don't expect anybody to be able to concurrently test the 4 million users that we have online in a test environment, but we wanted to come close to that. Well, obviously not that close, but somewhat close to that. And we were able to use Visual Studio Test Edition for that. And what that also does is it means all our quality assurance employees can also use Team Foundation Server, and it keeps it in one environment, which if we would have went with other tools, we would have had to go from unit tests, either using NUnit, and then we'd have to go back out to Microsoft, and we didn't want to do that. So we decided to stay with Microsoft through the whole life cycle. Okay, and then let me talk about the next thing, which was one of the bigger problems for MySpace, is that's deploying code. And believe it or not, early on we used Robocopy, and it would spawn 50 DOS windows and copy code out, and we all know that. And then we used NAMP for a while when we went to .NET, and that kind of worked as well. We had a lot of problems, so we fell in love with this new thing that came along called Monad, and then we became really good friends with Jeffrey Snover and learned, which became PowerShell, and we started to adopt PowerShell pretty heavily. So we wrote this product called Code Spew, and if we show you a demo of it, which we might at the end, it's a little green emoticon throwing up, and it's kind of how we throw code out to our site. We spew it out everywhere. And we needed something where we can maintain consistent changes, and we needed code rolls not to take 5 or 6 hours to push the code out. We can actually do a code roll now if we really wanted to our farm in 10 seconds now, but we choose not to, obviously, because we'd tip over the whole website to do that. You actually have to push code, do an IIS reset in some cases, or the app pull has to restart. And if you push code out in 10 seconds and all the app pulls restart, you guys can probably imagine what happens to MySpace. So, oops, let me go back. So Code Spew is a utility that's written, use Central Management Server. It's written with a WinForm API, a WinForm that hits PowerShell. It basically does a hashing on all the web servers. It uses UDP to go out because we're really not worried about losing packets there, but it does a TCP call on the way back in because we are worried about losing that information. So what it's going to do, it's going to go out, it's going to do a hash against all the files we're trying to deploy. If the hash is changed, it'll push code to those servers. You can do a lot of things in Code Spew like grep awk sed commands that you'd normally see in a Unix environment. PowerShell's really helped us do that as well. There's a security model for code deployment, so nobody can deploy code, obviously, that doesn't have the rights to do it, which is a huge issue. And we're able to execute remote PowerShell scripts across any server farm. We can check registry values. It really gives us a strong ability to deploy code to the 3,000 to 5,000 servers. I don't know if you had anything else to say.
That's
so,
good.
okay. And then I think it's you then. Okay, and then Jim Benedetto, our VP of Technology, is going to talk about how we deliver media and how we store media globally.
Last year at the Megasite presentation, we focused a lot on our databases and our database architecture and tracked the progress from day one to day of, I guess it was about 2.5 years as of last year, of the very different variations of our database architecture and our SAN architecture that we went to that enable us to scale the site. Well, over the last year, media has become a major part of MySpace, and we've gone through a variety of different architectures and designs of how we store, ingest, and deliver all of our images, MP3s, and videos. So I wanted to talk a little bit today about kind of the process we went through and how we got to where we are today with as regards to MP3, video, and image delivery. Just some quick stats. Right now, our image footprint consists of a little bit over 1 billion overall images. We store images in 3 different sizes, so the actual object footprint is 3 billion plus, but we have 1 billion individual unique images. We run checksums on all of the images coming into the system to make sure that we try to do our best to not store the same image multiple times on disk. Ends up being about 80 terabytes of space, and on the delivery end, we do about 150,000 image requests per second from our distributed file system. It averages about 8 gigabits a second. Music, we have about 25 million MP3 songs across the footprint. It comprises about 142 terabytes of space. And a very impressive fact for us, or something that's very difficult to do on our end, is the number of MP3 concurrent streams. We do about 250,000 concurrent streams at any one time. Similarly in videos, is really growing for us very quickly right now. We've got about 60 terabytes total storage. We do about 15,000 concurrent streams, but those streams are usually of a larger bit rate than MP3, so it's almost the same amount of data going down the pipe. And we do get about 60,000 new videos per day right now that we're ingesting, transcoding, and putting up for our users. So how do we handle all of this data? There's two problems that you deal with handling this amount of data. One is the amount of delivery, the fact that we've got a massive amount of long-tail content that we've got to stream to very large numbers of concurrent users 24 hours a day. That's problem number one. Problem number two is how do we deal with the amount of ingestion of the content? First problem we faced was that we were just pushing so much content down the pipe to the users that we were hitting a lot of bottlenecks and had a lot of issues. It wasn't until things really started ramping up that we started having issues on the ingestion level, where users were actually giving us so much content that we were having a hard time keeping up with just from an ingestion perspective. So we're currently in our 4th generation of our media encoding architecture. And what it does is it takes all of the millions and millions of MP3s, videos, and image uploads that we receive per day, recognizes the file type, properly transcodes the file. If it's an MP3 video, it does one thing to it. If it's an image, it does another thing. If it's a video, it'll do something else. And then basically transcode them, create thumbnails, do a variety of different things that we choose to do to that object, store it on a file system, and prepare it for delivery to the user. The big things that we've integrated in generation 4 of the media encoding is the ability to design custom encoding profiles, which means we can, with an XML file, take any video of any format, tie an XML file to it, and say we want this bit rate, we want this width, we want this height, this letterbox, and be able to transcode a variety of different formats. Now, when you're dealing with just the web right now, usually your bit rates, your width, your heights are about the same. But as mobile media becomes more and more important, the ability to transcode across a variety of different width, heights, and bit rates becomes more and more important. Another problem we face is that anytime we are transcoding videos or MP3s, it usually was a one-to-one relationship between a concurrent video encoding and a socket on a processor. We would find that if we had, let's say we had a 4-way dual-core box, we'd be able to transcode 8 videos at once, and each video would basically just peg one socket of the processor. So that was fine, but we found that as you scale to 300, 400, 500 media servers, you end up having sockets here and there. You're looking at managing thousands and thousands of sockets that we want to have maxed out at 100% all day long, every day, and just spewing the MP3s or videos across the farm in just a random fashion worked well. We started realizing that we found a lot of ways where we were losing efficiencies. We had some boxes that were running 6 sockets at 100%, but the other 2 were just sitting there. We didn't want to do that. We didn't want to have to go out and purchase more hardware when we had existing hardware that we weren't utilizing. So the key for us here is this job broker engine, which we developed. And what the job broker engine does is all of the encoding farms call home to a central server, or actually a farm of central servers, on I think it's 15-second basis that we've got right now, and just report their status. They say, I'm currently encoding images. I'm currently working on 3 images, 2 MP3s, 4 videos, and I've got 2 cores that are doing nothing, so send me some more files. So what we found is that as we were able to do this, we gained about a 25% increase in the rate of transcoding that we were able to do, especially for videos, because we weren't wasting sockets, we weren't having irregular distribution patterns across the farm. Another thing we did is that we abandoned the database connectivity layer in favor of a web service layer. Previously, all of the data, in Gen 3, all of the data was getting dumped into a SQL Server database, which worked fine, and then we could figure out how many transcodes we were doing a day by just running reporting queries against the database. But in Gen 4, we've actually left SQL Server and actually created a C# web service layer that we can then just call in directly, so we can have a variety of different people writing reports. Also, we've got an XML, which I mentioned earlier. We've got an XML-based workflow definition. So we can take any, and this is really something really cool we did in C#. We can take any type of file, give it an XML file that's paired with it, and then depending on what that XML file says, it depends on where in the farm it goes and the process that it gets in place. An example would be a video file that needs to be reviewed versus an MP3 file that doesn't. So let's say that we've got a video file that needed some type of review. It needed thumbnails created for review. That video file will have thumbnails created while an MP3 or an image file wouldn't. This is a quick encoding diagram. I'm not sure how easy it is to see, but it's a workflow of exactly what happens as we ingest content. You can see from a user content perspective, first thing the user does is upload one type of content. That content could be anything. It could be images, a variety of different formats of images, any type of format of audio or format of video. That is ingested through our upload farm, which are servers that basically just take the uploads, ingest files, do very little with them, other than determine what file they are, create an XML file, and hand it off to a job broker. The job broker then fires off the file and the XML, the object in the XML, to the media processing farm. Depending on what type, we actually are vertically partitioning this, so depending on what type of file it is, it might go to one of a variety of different media processing farms, which fully process the file, create thumbnails for categorization. A lot of the different types of files that we have, videos especially, we're required to take snapshots of and create thumbnails and run checksums and CRCs against. We create film strips for image review. We review all of the images coming into the site for different types of content. So those are film strips for image review are created. The web service communication layer allows interaction for anyone to actually come into the media processor and say, what are you doing right now? How many objects have you encoded? Where are we losing efficiencies? Where are the problems? The media processor then ejects the content properly transcoded to one of 3 different places. One is DFS 2.0, which is the MySpace distributed file system, which I'll talk about a little bit later, and then our CDN FTP server. For some of the content, we still use, especially internationally, we still use third-party CDN providers. So the media processor will upload directly to them. And the way we've built it, we can actually push it out to any potential application that wants to ingest any of the data that we've encoded. So MySpace distributed file system. This is something that we built over the last year that we wanted to talk about a little bit. What it is we faced a problem where we've got massive amounts of long-tail content. We have the footprints of our objects are so incredibly high, incredibly large, that it's very difficult for us to take the standard algorithms of just very, very fast disks with large caches in front of it. The reason because of that is because if you look at an object footprint of, let's say, 2 billion objects, that usually isn't a problem to serve as long as only 5 to 10% of those objects are hot. You can put that in an in-memory cache or use some of the standard caching architecture in order to be able to do that. We weren't able to do it with our objects because more than 5 to 10% are accessed. With our images, there might be 2 to 3% of our images that are incredibly hot, but the rest of the 98% of the image farm is accessed on a daily basis. Maybe not as frequently, but it's still accessed on a daily basis. So the cache churn would be so significantly high, we couldn't use standard caching algorithms in order to be able to serve the images. The same thing applies to MP3s. An interesting thing you'll see with MP3s on our site is very different than a lot of other MP3 streaming websites, where people don't come in and they don't listen to the first 3.5 minutes or the entire 3.5 minutes of an MP3 song. If you look at standard MySpace traffic, users click around profiles very, very quickly. And if other users have MP3s on their profiles, you could have a user clicking around 15 clicks, and with those 15 clicks, they've individually started 15 individual MP3 streams where they only listened to the first 7 seconds of the MP3 and then left and went to another profile. So the MP3 streaming patterns were very different as well. So the MySpace DFS is an object-oriented file store. It's a dumb file store that basically allows ingestion of objects and very fast retrieval of those objects. It scales linearly to what we believe to be near infinite capacity on commodity hardware. We've built it horizontally partitioned, and it's a single namespace across many, many different types of commodity servers. It's very high throughput distribution architecture. It's got a simple cross-platform storage or API, so any type of software can come in and access it. And it's been designed exclusively for the very specific long-tail content that MySpace faces. We were able to look at our content very, very closely and build a file system that works especially for this type of content. Sledgehammer is what the MySpace DFS is codenamed, and it's a custom, high-performance, event-driven web server core. We wrote it entirely in C++. We were able to integrate a content cache engine that enables us to cache a significant amount of the content. A lot of the content actually doesn't end up being cached just because of the size of the footprint. But we were able to run some special caching algorithms that allow us to get as high cache hit rates as possible. It integrates very closely with a MySpace DFS storage layer over HTTP. Every cross-node communication is done through HTTP. We're able to stream about 1 gigabit a second through a dual processor host if we're looking at larger files such as MP3s and videos. We obviously don't get that with images. And we're also capable of tens of thousands of concurrent streams. Next slide, please. Just some interesting facts on the MySpace distributed file system. We use a generic file pointer data type for identifying files. Every file is actually matched to a URL, which is accessed or posted to over HTTP. It enables us to change our URL formats. A lot of times if we move from one CDN to another, we're moving into a new country, we're deploying in China, we're going somewhere, we want to be able to manipulate our URLs. And one thing we ran into initially was the fact that if we didn't abstract the URL manipulation away from the storage, we ran into a lot of problems. We've made it so it's still compatible with traditional CDNs like Akamai. Even though it somewhat is a CDN of its own, we can still use it as a sourcing engine to other third-party CDNs that we choose to use. It can be scaled at any level of granularity. So what we're able to do is we're able to increase the storage from a single node perspective, or we can actually drop in entire clusters and vertically partition the clusters. And then also we've had a uniform method for any of our developers to come in with any language, C# or any other language, to come in and access any of the media content that we have on MySpace. We've got a couple presentations now that we'd like to give. We probably want to open up the floor to any questions right now of what we've already presented, and then we'd like to go into some presentations, one of CodeSpew and also of the PowerShell code that we have underlying our CodeSpew application.
Yes, I had a question about software innovation versus hardware innovation. I mean, where do you guys see, like, how much do you depend on hardware innovation versus software innovation to get this site to continue to scale?
It's a good question. I can show you a chart right now. If you look at this, these are just some operational wins that, and I promised I didn't have this queued up. You just asked the perfect question right in time. We've been looking at just the operational wins that we've been able to do over the last 3.5 years, one of which is refactoring and additional software efficiencies by refactoring our code base using C# versus the previous code that we wrote the site in. And then actually going back and refactoring our C# code and actually trying to gain more and more efficiencies from the individual code. is one way that we've actually been able to see significant efficiencies across the entire site, and overall just reduction in the capital cost of running the site, the ability to have to actually not buy as many servers. And two is over the last 3.5 years, we've seen amazing gains in processor speeds. And if you look right now, this is the operational wins that we've been able to see of just a pages per second from a server we used in 2005 versus a server we used in 2006 versus the new servers that we're purchasing today. And we've seen major wins on pages per second, if you look at that metric, which can be directly correlated to pages per dollar of capital spent, or also pages per power. Right now, power consumption is very important to us. So these new servers, even though they're able to serve a lot more page views and able to run at faster clock speeds, they draw a lot less power from the data center. So I'd say both. They're both really important. We're constantly refactoring our code base, but we're also, as soon as any of the new low-power processors come out, we're buying them as fast as we can.
Some of the biggest gains we saw actually were on the database side when 64-bit came out.
Yeah.
We were able to load the boxes up with RAM, and databases love RAM. So that really saved the day for us when we actually started using native 64-bit hardware and native 64-bit SQL Server as well.
How many QA engineers do you have, and are you using any other tools besides Visual Studio Test?
Yeah, we have 21. We have the strategic test engineers, quality analysts, and QA engineers. Basically, yeah, we are. We're using some of the HP Mercury tools as well for our C++ MFC-based apps, our instant messenger client, but mainly we've tried to stay with the Visual Test Edition. And one of the main gains that we're going to get out of that is you're going to be able to take all your tests, and we're writing a shell that can run against our production servers, so exactly what you QA against our test environment, you'll be able to QA against production, because we run a horizontally federated environment. So for every million users, there's a million user database. So you actually have to test sub-combinations. So a 1 million user sending mail to a 3 million, a 1 mil to a 4 mil, a 1 mil to a 5 mil. And if you don't test all those combinations, you obviously could miss something, not just at the code level, but at the production level. So mainly we're probably about 90% Microsoft test products.
Hi. Can I ask if in the last year you've considered some of the commercial caching frameworks like Coherence or Gigaspaces? And if you haven't, an indication as to why?
We haven't done much consideration of third-party caching engines, mainly because we have the ability to write them ourselves, and we also, kind of one of the themes of MySpace is we usually tip anything over that comes from off the shelf. So we like to have a lot of access to the code and be able to customize things, especially for our traffic patterns. That's one of the things we really take advantage of is analyzing our specific traffic patterns and then designing a system around that. We did that with DFS, and we did that as well with our caching.
Yeah, and I will add to that. Early on, when we were looking for caching, we kind of fell in love with the concept of memcache from Danga, which I think originated up into LiveJournal before anywhere else, and then Slashdot. And what we really liked about it was a dumb cache. You could throw boxes at it. We've also, like Aber indicated, we blew through .NET remoting. We heavily look at Windows Communication Foundation, but we wrote our own, on top of the WinSock API, we wrote our own relational cache. We run about 1.9 terabytes of RAM, and we're going to have about a 54 terabyte Berkeley DB persistence layer. And we wrote a really cool 64-bit .NET wrapper around Berkeley DB, which I think both Microsoft and Oracle was excited about, because we're now able to talk natively in 64 to Berkeley DB.
I would like to ask a question regarding how do you handle the geo-replications and issues associated with synchronization on geo-replications?
It's a good question. We're actually working on that right now. Previously, we haven't had to worry too much about synchronous geo-replication. We've been able to do it asynchronously, and we've been able to do it from active, passive sites. When you get into active, or active replication of data that's inherently as highly interconnected as social networking data is, you run into a lot of complexities involved. What we've decided to do is, one, we looked at potential SAN replication of just for primarily DR, disaster recovery purposes, looked at initially using block level replication that's not aware of the actual overlying data. It's just moving blocks across the pipe from sand to sand. We're actually doing that now, and it works, but it's not really what we'd like to do. Once we look at potentially having to build data centers in other places around the world where the internet's not as fast as it is, here in the US or over in England, and we look at potentially replicating the data across multiple sites, you need to have an application that's actually aware of the nature of the data instead of just moving bits and moving blocks. So what we've developed is we've developed something called we're actually in development of something called the Transaction Manager. And what that does is it's very similar to what Aber presented as the relay system. But as the relay system is ingesting data from the databases and feeding it out to the users, what the Transaction Manager is doing is taking data from the users and holding it and queuing it before writing it to the database. So it's kind of like a reverse cache. So any changes the users make will go into the Transaction Manager with a metadata tag that says this is a new comment, this is a new piece of mail, this is a new user, this is something. And then the metadata will actually tell the Transaction Manager what to do with it. An example would be, this is a new comment posted by user number 122 million, who is a user out of London. Write this, first off, around the global coherent cache that you have around the world. Replicate this data out to the entire cache around the world, A. And then B, persist this to the databases in these locations. So it's still done asynchronously, but what it's done is we write to cache first, and then we persist the data to one of many databases in a variety of different locations depending on what the metadata tag tells it to do.
Application is with DFS. So we need to maintain geographic redundancy. So when a user uploads an MP3, we transcode it on the background in the background. So we also maintain synchronous replication in the background since the user isn't waiting for it.
But the questions that we face, that I think anyone would face when they're trying to deal with geosynchronous replication is, one, how interconnected is the data? And two, can I replicate it at just a block level? If you're not doing with highly interconnected with data and you're able to take it and use replication of just SAN-based block or bit level replication, it becomes significantly easier from an engineering perspective.
Go ahead.
Yeah, I had a question about, you talked about your 4th generation DFS. How do you change major infrastructure like that and put it into production? What's your rollout strategy?
We have, the way we generally roll code is we soft launch everything. Once the developers say it's done and we put it through QA, we'll usually take the code and roll it out to a small group of users. Every time we roll something out, there's knobs on the system where we can launch it to 1 person, 10 people, 100, 10,000, 1 million. We'll scale that up until we can test functionality but also scalability. Usually that's one of the biggest problems we have. It works fine in a dev environment, but once millions of users start hitting it, all of a sudden it blows up. So we'll slowly roll it out to incrementally more users. For something like specifically with DFS, it's actually a lot harder to do that. So we'll try to test it as much as we can, but then roll it out at a very low traffic hour and have a very fast rollback plan. Anything that's not code related that we can't use with users will just generally have a rollback plan that's really, really efficient.
Yeah. And I guess I'll add to that is, about 2 years ago, when you have RoboCopy and you're writing in Cold Fusion, you can roll every 5 minutes if you want. It was only in the last year that we stopped rolling every day. MySpace, we try a lot of stuff. We want to see what users like. The president of our company, Tom, literally through a few people and himself read all the mails that come into MySpace and try to aggregate what users want, and that's how we've stayed a niche in the market and grown. We also now have a hotfix path, so if we are pushing code on a Wednesday and we need any changes for the following Wednesday, we'll just pull back that branch, hotfix it, and then we'll redeploy out again. The one thing that is changing for us now, and we'll have to handle the next year, is We are growing in China as well with MySpace China, and we'll continue to grow this year with it. So downtime is going to be a lot more even than it's ever been. When I first started the company 2 years ago, we'd basically, from 7 p.m. until 11 p.m. on especially a Sunday, Monday, Tuesday, so after everybody gets home Sunday all the way through Tuesday, it'd be a really hard-hit environment, and then it would be easy. By 11, 12 o'clock, we could roll code, and that's no longer the way it is. Go for it.
What kind of load balancing technology are you using? And are you using any of the web acceleration features, TCP multiplexing, caching, compression built into them?
Well, we have a few different load balancing schemes. One is the third party, which is NetScaler. We do use HTTP multiplexing, which we do get good performance gains out of. We don't use any other features, specifically compression or SSL, because it's not very scalable. If you use compression on a load balancer, you're generally going to eat up a very expensive CPU there. Where if you put compression down on the web tier, not only is it very cheap CPU that you can distribute out, but it's also smaller packets going through the wire up to the load balancer. A couple other load balancing technologies we use. We use custom load balancing algorithms on our caching tier that our developers can choose from, round robin or least connection type algorithms down to that tier. And then we also use another type of load balancing, which is Akamai's Global Traffic Manager, where you can put, specifically for DFS, you can just put servers just out on the edge with their own firewalls on them, and then have IPs be load balanced in DNS, which is a very efficient way of load balancing if your application can handle it.
Another thing that we've looked at in the past that I'll touch on that we do use for some of the smaller applications on the site is something called DSR, which is direct server return. And with the NetScalers and with a variety of different load balancers, load balancers are great. We continue to add the hardware load balancers for the HTTP content, the highly progressible content, and the content that doesn't require extremely massive amounts of bandwidth. And when you start pushing massive amounts of bandwidth, having to have load balancing farms in front of all that bandwidth becomes incredibly expensive. So you try to find ways to actually get the benefits of the connection multiplexing and all the benefits of the security of a NetScaler of a load balancer without having to buy enough to push 50 gigabits of MP3 traffic down the pipe. We've currently moved off and are using what Aber spoke to of round-robin DNS, but one thing you can look at doing is something called DSR, which is direct server return, which will enable you to have all of your incoming connections come through your load balancing farm, be properly load balanced to individual servers, but then the servers open up direct TCP/IP connections with the client. So you actually don't have to pay for the load balancer bandwidth on an outgoing capacity. You're only paying for the load balancer bandwidth on an incoming capacity.
Hi there. Given how you guys do your testing, your database scaling, and all the other tactics you've talked about in this and the other presentation you did, I'm interested in how you actually do your configuration management in terms of the capability to roll back and forward in versions, especially in how the code relates to the database too, and database versioning.
Okay. Do you want to talk about the database thing?
Yeah. We use CodeSpew to maintain all of the code and consistency of code across the entire farm. We've got 7,000 web servers, and it's very difficult to maintain code across that many servers, especially when you're frequently pushing code. It's also very difficult to maintain configs. A lot of different applications run on all these different servers, and there's a variety of different config files across all these servers. So maintaining proper configs and making sure that there's not 5, 10 servers out of 7,000, which is significantly less than 1% of your servers are out there with a different config, was very difficult to do, which is why we wrote CodeSpew. And what CodeSpew does is it goes out, and as Alan spoke to, it's doing CRC checks of the entire code base and ensuring that if anything of this code base is changed from our master gold image to immediately push, or it actually is a pull, immediately pull code out to the outgoing servers. From a database perspective, we have our own internal versioning system, but we're currently looking at using, we're using TFS?
Yeah, we're
currently looking at using TFS for our SQL versioning. Our current versioning system is not up to par with the versioning that we're doing on our caching tier and our front-end presentation layer tier. So we're looking at migrating. I believe the new version of TFS supports.
Yeah, with Visual Studio for database professionals.
So we're going to start using that for all of our SQL and actually try to tie individual SQL pushes to web config and presentation layer pushes as well.
Yeah, we roll over every 3 or 4 days to a new million user database. So we've gotten pretty much in the mode of setting up the configs at that level.
It's not an easy problem to solve, though. We've gone back and forth on different methods. One way of doing it is having a centralized configuration server and knowing that all the servers can go back when that's changed. The downside of that, if you screw up the config on the centralized server, you're down. Another way to do it is to have CodeSpeed be responsible for it, but it doesn't guarantee that your configs are the same. For if there's a network error or something, then it may not get pushed out. So we've gone back and forth. Microsoft has some new features also, kind of the centralized configuration and code that's coming out with Longhorn that we'll consider using if it can scale.
All right, if we have no other questions right now, we can go into a presentation that we put together. It's a video. If you guys can cue the video back there. Don't fire it off just yet, though, but if you can just cue it up. We've got a presentation of how we use PowerShell. When PowerShell came out, we were able to look at it as, wow, we can now manage these thousands and thousands of servers from a single console. It was huge for us, and it was what CodeSpew, which is pretty much a GUI application just built on top of PowerShell, so you don't need to actually know PowerShell in order to do it, came about. Instead of showing you the front end of CodeSpew, I wanted to show you pretty much what we are able to do with PowerShell. We've got 6 different PowerShell commands queued up right now that I'm going to show you that we do. One of which, do we have the video going there?
Here we go.
Don't start it just yet, but one of which is, can you? All right, we'll try to do this in real time. What we're doing is, what we're going to do is we're going to run a PowerShell command that's going to go out and say, show me a list of all of my servers in my profile VIP. So I've got profile.myspace.com. I've got 7,000 servers. How many servers are in the profile VIP right now? We're constantly dynamically moving servers from one particular VIP to another VIP based off load, based off a variety of different things. All the servers have the exact same code base on them, so we can move them from mail.myspace.com to profile.myspace.com very, very easily through all of the Netscale or SOAP interfaces. So what I want to do is I want to find out which servers are in my profile VIP. What I'm going to do is I'm going to run a PowerShell command that's going to go out. It's going to grab all 7,000 servers from Active Directory from my local domain controller. It's then going to go out and say, what are the IPs of all of the servers in profile.myspace.com from the Netscale or SOAP API. It's going to mash them up, and it's going to give me a list of all of the current servers that are in profiles.myspace.com. Okay, you can go ahead and fire this off. Now what I'm doing is I'm going to say get all the servers in my profile VIP that are currently up and serving traffic. If you pause it again. What I was able to do is say, give me all the servers that are up and serving traffic. Anytime you have 7,000 servers are going to go down. Happens on a daily basis. What we have is we've got Netscaler health checks that are able to go in, and as soon as a server is taken offline, we're pinging port 80 from the Netscalers on the servers all day long, and as soon as a server falls offline, the Netscalers immediately pull it out of production. So what that command actually did is it first said, show me all of my servers, and then the next command said, show me all the servers that are actually actively serving traffic through the Netscaler. The next command is going to do something that's very interesting. What we've done is we've written a server agent that actually lives across all of the servers. CodeSpew, the central server, actually fires out a UDP broadcast to all the subnets and says, it's time for a code push. The server agents come back and open up TCP/IP connections back to the central CodeSpew server and accept their code push. Well, once we had our own server agent running as a service across all of our web servers, we started thinking about a lot of different ways we can use it. One thing we can do is we can actually now remotely execute any approved PowerShell command from from a central location. So if we write a PowerShell command that says join this domain, or we write a PowerShell command that says run this SQL command against your local database, we can fire that PowerShell command across to all 7,000 servers in the farm, all 400 databases, any servers in the farm, and have them instantly access it and run it. What this is going to do is this is going to execute code across all the servers in the farm right here. We're actually going to say only servers that are up in the profile VIP run hostname.boo. What this is actually doing is we're going to show you what hostname.boo is. It's an application that we wrote just to test this that actually just has the servers print out their DNS lookup. You can go ahead and play the video. Basically, it's just saying console.writeline get hostname. But all 500 servers that were up actually ran it locally, spit it back to the central server, and displayed it. What this is now doing is saying get perf profile. So this is saying go out to all of my profile VIPs and show me the perfs. Show me the CPU, the requests per seconds, the number of queued requests, and the unhandled errors per second of all of the servers in the VIP. What I'm going to do again now is say get perf profile. Show me all of the servers in the profile VIP where requests queued is greater than 10. So show me any servers I have in production right now on the profile VIP that are actually blocking more than 10 requests from incoming users. It didn't work, so now we'll try greater than 0. And that shows us any servers we have that are potentially queuing database requests or queuing front-end requests. Finally, we can look at executing remote code, which will be able to show us perform an IIS reset across the farm from a local command shell. This is saying any servers that have a queue of greater than 0 run a local IIS reset across them. Reset any of the servers that have queued requests. Okay, you can stop the video. But that's just a quick example of 5 or 6 of the things that we do. We actually use PowerShell exclusively now across all of the servers in the farm in order to manage them. It makes manageability of them a lot easier. And the CodeSpew application that actually deploys the code is a GUI built on top of these PowerShell commands.
Okay. We've got a few more minutes left if there's any more questions. Otherwise, we'll go ahead. I'm sorry? Yeah, definitely. Go ahead.
Hi, so you've mentioned a couple times that you have your user databases federated in million user chunks. How has the ratio of sort of active accounts to stale accounts changed over time? Like I would imagine maybe you have better hardware for that first million users for MySpace?
Yeah, we do a couple. When you're dealing with range-based partitioning, the downside of it is you can't guarantee that there won't be hotspots across the federation. So we overcome that a few different ways. One is we virtualize all of our disks, meaning all the databases share a back-end disk architecture, so that if one database in particular gets hot, say the newer database that we're using, then it'll just use more of the shared disk resources. And then we can also mitigate that with the caching tier on top, where almost every read comes out of the caching tier, so we only go writes down to the database. But to answer your question in particular, usually the newer ranges are the hottest because the users are registering, uploading a lot of their pictures, building their accounts, customizing their profiles. And then over time, we get those user accounts will drop off, but then the older users are usually very active with high number of friends, high number of messages. So it actually evens out pretty well.
You see statistical issues early on with the new databases that we see is that when you look at if you've got a database packed with 1 million users, it's got the average amount of comments, it's been around for 2 years, the query plans for that database usually stay the same. But you got a lot of dynamically changing query plans. If you have a database with 0 users and you fill it up with 1 million users over the course of 3 days, the query plans that worked 3 days ago no longer work today. So as we roll over, we continually add new databases and point the fire hose of horizontally partitioned fire hose of users into these new databases, those first few days we really have to be consciously watching the databases, and we have a lot of scripts that run to make sure that we're maintaining the statistical patterns, because we're going from no data to lots of data very, very fast in each one.
Yes, are you using any virtualization technology in your infrastructure? If so, what and how and why?
Well, we don't virtualize on the web side, we actually do. We have a virtualized infrastructure for our staging and development environment. So whenever our developers want to use a fresh server, they'll go to our development environment, which is all virtualized. Then another area where we virtualize is all of our disk architecture. Yeah, the back end is complete. There's 7,000 disks all virtualized into a single volume, essentially. Anything I missed on that?
No, really. Yeah, I mean, to Aber's point about the dev environment really quick is, we need to give each dev team, because we vertically dev features, a caching server, and sometimes still a Cold Fusion server, although most teams don't need that anymore. And we're converting the rest of the Cold Fusion now, which is basically our community features like forums, blogs. And then after that, we'll pretty much, every team will get a few caching servers, a few web servers, and then we might do, not virtualized, but we might do hardware data snapping at the SAN level to give you production level data before you go out to production.
Your data access layer, are you guys using a lot of T-SQL, or you're doing lots of stuff in C#, or what's the mix there?
Yeah, that's interesting. We started out using the patterns and practices guides probably before .NET 2.0 came along for our data access layer. And then we looked at whether we were going to use declare it. And I don't know if you're specifically talking about, like, we're looking at things like link as we go on. We've met with the ADO.NET team to talk about where they're going with link and where they're going with entity-based diagrams. But mainly, most of it is still typically stored procedures that we wrote our own data access layer with business objects. We have a business framework team, which is just a really new thing for us, where they focus on business objects, whether the business objects are going into cache, whether the business objects are calling stored procedures, and then the front-end developers get a very enterprise-level SDK or API that they can call into. Because of the growth of our company, we don't want a lot of people touching the DAO. So we have a team of about 5 or 6 people that we trust to write the business objects and define the DAO.
Yeah, our goal is to abstract all of the data access from the developer, mainly because we want everything to run through a caching system before it hits the database. And yeah, it's 100% stored procedures. Yeah.
Could you describe your content aging out policy and if you've changed that over the years?
Content on the caching tier, or content? What do you mean by that?
Your users' content. How you manage the aged out content that really isn't getting accessed, or whether you even do.
Yeah, we don't do that. We don't. Currently, all 180 million accounts are active. We haven't really had a need to delete older accounts because we just don't have an issue with the amount of storage in our backend infrastructure. We've always maxed out the I/O on disks before we can fill them up, so we just haven't had a need to delete accounts. There are certain areas where the things build up very quickly, like mail. For sent items and trashed items, we run jobs to delete those. We also have fairly transient data, like bulletins, that we only keep around for about a month. So there are certain policies that we use, but for the most part, we don't delete very much.
Yeah. The relay caching tier is all LRU based. So if no one has come and accessed your profile in a few hours or a few days, you're going to be just sitting on the disk. And as Aber spoke to, sitting on the disk right now is not additional cost for us, because we already need to have the disks from an I/O perspective. That all the disks we purchase are based off I/O per dollar, not gigabyte per dollar.
There is an age-out algorithm on the caching tier, which is LRU. So the older stuff naturally goes away.
And where we're evolving cache now, and the reason we talk about Berkeley DB and we talk about a 64-bit wrapper for it, we currently don't have a disk persistence tier to our cache that's really enterprise level. So what we're going to be able to do is tune certain virtual VIPs. So like profile data, shared data where there's 15 things about you that we want us to keep in a shared repository. We probably keep between a 92 and 99% cache hit ratio on those, and it's all memory-based hits. Now, what we want to do in the future for forums, for comments and other things, we might want to store 60% in memory and store 40% on disk. So for certain virtual VIPs, we're going to be able to dial in how much goes to an I/O and how much goes into memory.
All right, guys. Well, we are, MySpace is hiring very aggressively. We're looking for talented engineers. We're actually having a recruiting party at Pure on Wednesday night, if anyone's interested.
Tuesday night.
Tuesday night.
So we'll be there if you want to come by, and we're going to be around for a few if anybody wants to come up and talk to us as well.
Thank you.
Okay, thank you.